Welcome to the foundation year. My name is Jim Shank. I'm a reader in mathematics at the University of Kent. This means that I do research in mathematics and I teach mathematics. And my research focuses on the interaction of algebra and geometry. And I'm particularly interested in the symmetries of polynomial functions in several variables. So that's the sort of the research that I do. So this year, I will be the lecturer for the foundation year mathematical skills module. The goal of this module is to help you become a better math student. Now, a good math student not only knows how to do the calculation, but they also know why the algorithm works and how to interpret the result, how to communicate their conclusion. So these skills are what this module is all about. Now, as a warm-up, I'd like you to think about the postage stamp problem. I'll start with an example. So suppose we have a supply of 4p stamps and 5p stamps. So what postage values can we produce? We're going to have one integer, the smaller integer 4, second integer 5, and we want to know what values we can construct from these two postage stamp types. So we'll make a little table for yes and a little table for no, and so we can certainly get 0, but we can't get 1, 2, or 3. We can get 4, and we can get 5, but we can't get 6 or 7. It's possible to get 8, is 2 4s, and 9 as a 4 and a 5. And 10 is 2 5s, but you can't get 11, no matter how hard you try. Now 12, that's fine, 3 4s, and 13, maybe I have to think, but 2 4s and a 5. 8 plus 5 gives me 13, so that's fine. 14, 2 5s and a 4, and I claim that I can just keep going, that all of the other values can be achieved. So that's my claim, that we can produce any value greater than 11. Okay, so here's a challenge for you. Can you prove this? Do you believe it? Well, let's think about maybe another example. What if we'd have, say, m equals 7 and, oops, where are we? M equals 7 and n equals 11. So is there a largest unattainable number in this case? And if the answer to that question is yes, well, what is it? We could also say, well, what if we took m to be 9 and n to be 12? So you can start to see a more general pattern here, or you can start to see a family of questions. If you give me any two integers, is there a largest unattainable number? And if there is, then what is it? So could you find a formula or criteria on M and N, which would tell you when there is a largest unattainable number and how you might compute it? So you can see this is I think, an interesting family of problems. You could even extend it further and say, well, what if we have three numbers rather than just two? Yeah, so the even greater collection of problems we might look at. So let's just stop that for a moment and go back to gallery view. So I think that's an interesting problem. There's some actually quite serious mathematics lurking in the background, and but the formulation of the problem is fairly simple. So I think it's gives you a challenge, something to think about. Could you decide, explain when M and N have a largest unattainable number and how you might compute that number as a formula for M and N. So it's a kind of a problem to solve. It's a bit of proof. And you can also think how you might communicate your solution, how you would explain your solution to a fellow student or to me. So these are all the sorts of things we want to think about in this module, not terribly sophisticated mathematics, but interesting ideas. How do we think about numbers? How do we think about mathematics? How do we express ourselves when we want to talk about mathematical ideas? So these are the sorts of things we're going to think about in this module. So anyway, I look forward to seeing you in September, and have a good time for the rest of the summer.